In this tutorial we'll have a look at how we handle files that have been generated by RED cameras. As with many formats, Mistika will load the R3D file format directly and doesn't need any transcoding on the way in. But because the R3D format is a raw camera format, Mistika has some specific facilities that allow us to access the settings that were applied to the files within the camera. To access those parameters, we simply select our RED file or files and go to Effects and use this R3D params. So I'll double click and we can see we have a list of camera settings here under our parameters. Most are self-explanatory. So for example, this is the color temperature setting that was in the camera. The reason we can access these parameters is to do with the way a RED file works. The RED raw data is the data that comes straight from the camera sensor. Then if the camera operator applies any changes in order to produce a particular look, those changes are applied downstream to the data. They don't actually change that original data. They're just changing the way the camera operator views the data. So as a result, we can intercept those decisions and change them, override them, or just accept them. So as we'll see if we open these parameters, most of them are saying source. What source means is that I just want to use the same settings that the camera operator left. Alternatively, I could override, change to value, in which case this value now becomes relevant. So now changing the color temperature, for example. In some instances though, it would be helpful to know precisely what value has been set. For example, if I went to gamma curve here, I can see that I'm on source at the moment, but I don't actually know which one of these it is. Of course, I could keep clicking through until I found the one that looked about the same. But there's two easier ways of doing that. Firstly, if I go back to the timeline and select the RED file, under Edit and Attributes, here is a list of all the attributes that are set. So in fact, in the case I was just looking at, that was the gamma curve there. Alternatively, under Edit and Macros, we have this Load 3D Params here. And what this will do, if I click it and then go back into our R3D Params effect, you can see that it's actually loaded all the settings. So now none of these say source, they actually say the specific value. Now you'll note that even before we have R3D Params on the clip, we're still seeing an image. So obviously there are some settings that are already being chosen in order to make this particular image. These can be a combination of the settings that we inherit from the camera, but also actually under the mconfig program of Mistika, which we can access from Edit, Externals, mconfig. We can see there's a RED tab, and under here we can force certain variables. Everything is unforced, which basically means inherit the camera data. But I could also override as a default position any particular parameters. Personally, I tend to only do that in the timeline so I can see visually what I'm doing to the files. An interesting one though is reduce factor, which at the moment we have on 2. So let's go back into R3D Params to explain what that does. As you can see, under R3D Params folder, we have the reduce factor as well. And at the moment it's set to mconfig. So in other words, it's picking up the number that we set in the system setup. But on a clip-by-clip basis, it can be overridden to be a 1-to-1, 1-to-2, 4 or 8. So what does this mean? Well, RED, like many digital cameras, uses an image pattern called a Bayer pattern, which is a particular way of storing image data in a manner that's very efficient to handle resolution and detail. However, it's a different picture format to how we would normally look at an image in terms of, for example, RGB pixels. So we need to go through a process called debayering to go from the bayered image to an image that's easier for us to see. And in that debayering process, we can choose whether we're going to do a full debayer, a half debayer, a quarter debayer, or 1/8. A full debayer gives you the highest quality. The lower you go with the debayer number, the poorer the quality, but the faster it will go. This ratio has a direct effect on output resolution as well. So for example, if I leave this on 1:1, and just in our timeline I'll just go in and add a framing tool, as we saw in the multi-resolution tutorial, and double click on here, and we can see that the source resolution coming from that red file is 4K by 2 and a bit K, which is a standard 4K red file. Now if I drop back to the R3D params and put this down to 1:2, a half debayer, and go back to framing, we can see that our output resolution has halved. However, our debayering speed would have increased, and for example at the moment most Mistika systems would be able to play a half debayer in real time, whereas it's perhaps unlikely to play a 1:1 debayer in real time. Now of course, if your output is 1920 by 1080 HD, there is an argument that as long as the half debayer is done reasonably well, that this output resolution is adequate. And of course within Mistika you can test whether you think it'll be adequate or not, because on a clip by clip basis you can change from a full debayer, so that's now looking at a full debayer, to a half debayer. Now we can't see very much change there, so let's have a good look in. So that's a half debayer, and that's a full debayer. Chances are on the compressed Vimeo stream you're watching you probably can't tell much difference, and I have to say, even looking at the original file, it's reasonably difficult to see too much difference here. So that's why sometimes if I'm working at HD or below with just normal images, sometimes I consider that a half debayer is adequate. Although for example if I'm working with green screens or something that I know I'm going to track, then perhaps I would be a little more persuaded to go to 1:1. But the nice thing within Mistika is that we can change this at any point through our project. For example, let's say I put it down to 1:4, which is now going to give a relatively poor quality of image, because obviously we're dropping the image size down to below our output format, in this case being HD. But the result would be that I'd be able to navigate around very, very quickly. So one method actually is, if you were editing, so let's just build myself a fake timeline. Imagine all these are different shots. So at the moment I have all these shots running at a 1:4 debayer. So let's just set a rescale just so they're all full frame. And again I can just set that to go to all clips. So now I have a timeline that's going to move nice and quickly for me for my interactive session. For example, if I were going to set up a color grade, for example, to do something to the images, and again let's just send that everywhere. So now I've got a graded timeline, and I can move around it nice and quickly because I've got my debayer setting quite low. But then when I come to output, what I could do is go into one of the R3D params, put it back up to 1:1, select just that parameter and propagate it to all the clips. So now all the clips on the timeline are doing a 1:1 debayer, meaning the result is absolutely full quality for when I come to output. In terms of handling speed, it wouldn't be quite so interactive now, but I've done my interactive bit, so that's fine. One other word of warning about using the reduce factor is if you did come to the view that you were happy, for example, to use a 1:2 debayer, because perhaps this is substantially higher than your target resolution anyway, then do beware that this is a straight dividing number on the original resolution. So if you're satisfied that 2K is good enough for what you're doing, of course that's assuming that your original input is 4K. A red camera doesn't necessarily always record at 4K or 5K for an epic. As the frame rate increases, for example if the camera operator is shooting in slow motion, then it can be made to shoot at a lower resolution. So then of course if your original file became 2K not 4K, well now your output resolution from a half debayer would be 1K not 2K. So you need to keep a little eye on this if you go down the route of using a lesser debayer value in order to give you more speed. Let's just pop back and look at one other thing in the list of parameters, I say most of these are fairly obvious and you should be able to find them in the manual or references to them from RED themselves. This is an interesting function here that's specific to an Epic camera, which is track. It would normally be on track 1, but in very special conditions you might also use track 2. This particular file doesn't have a second track, so there's no image there. What this relates to is Epic's ability to effectively shoot 2 exposures of a scene. And so what would happen if an Epic camera was so set up is that in track 1 you'd see the result of 1 exposure from the camera, and in track 2 you'd see a different exposure from the camera. So within here you could choose which of those 2 exposures gets exported effectively from the R3D params. Now it'd be subject to a more advanced tutorial, but one of the methods that you could use with that is you'd actually duplicate your clips, and you'd have one of the R3D params exporting track 1 and the other one exporting track 2. So within your timeline you have both. And then actually you would use this effect here, HDR merge, because what that will do is take the 2 different exposures and map the 2 together to make one high dynamic range image, where you have a lot of detail in your lowlights and your highlights ready for grading. On the face of it, it sounds like a great idea. There's a small caveat in that, which is that the 2 exposures don't necessarily happen at exactly the same time. But of course, in order for an exposure to gather more light, the exposure by its very nature has to be longer. And so what you'll often find is that one exposure has more motion blur than the other, or possibly an offset in time. In which case, there are functions under this optical motion blur which would allow us to retime the shutters to match each other and to estimate motion blur on one exposure to match the other. But as I say, that's perhaps something for a more advanced tutorial.